In this video, we are going to understand about a very important concept called combination. Okay, see, whenever we talk about combination or choosing or selecting or any of these things, or you can also call grouping. Now, this mathematical concept has a lot of practical application. Okay, apart from the theoretical examples, what you might have heard and what you might have seen, there are lots of practical applications of this particular concept. Okay, now I'll give you one practical application of this one. The concept of combination is used a lot in game theory. Okay, now game theory is that particular concept where it is used in many of the games, whatever arcade games, puzzles, different types of mind related games. Okay, when I say mind related games, where you have to use your brain and solve, those kind of things. Not only that, it is used in stock market. Okay, probability it's used, and many concepts, like many branches are there where combinations are used. Now that you know that it's used in a lot of cases, let's try to understand the basic mathematical theory behind it. All right, now to understand the theory, it's very simple. What we have is, you have 1 2 3 4 5 6. Assume that there are 6 people. Okay, let's call them as A, B, C, D, E, F. Now, out of 6 people, I have to choose or I have to select. All right, I have to choose or I have to select, let's say 3 people, to make sure that I'm making a committee of 3. So we have 1, 2, 3. Okay, so think of it like this. Imagine it's a reality show and you're going to have 3 judges, right? So there are many candidates for you to select. So let's say that to select those 3 judges, we have shortlisted 6. Okay. So the first judge I'm going to choose, let it be C. Let C be the first judge. Then I'm going to choose E, and then I'm going to choose A. All right. Now, when I choose C, E, and A, okay, imagine 3 judges of a reality show. Now, tell me one thing. Do I have to always choose C as the first candidate? Can I not choose E first, then A, then C? Does it make any difference? No, right? Because the judges are the same. So, when I'm saying select or choose or group or any of these words, a very important thing or very important mathematical concept is combination. Because how many are available to us? There are 6. And how many am I choosing? 3. So out of 6, we are selecting 3. So if you generalize this, that means we are going to have n number of things, out of which we are selecting R. So mathematically, we write it as NCR. That is, out of n, we are selecting R. That's why we write NCR. Okay. Now, to understand that NCR concept, mathematically how we are going to write it, let's take the same judges example. See, we have CEA as one way, EAC as one more way, correct? Or I can also write this as CAE, one more way, correct? Or ECA, or AEC, or ACE. Now, if you look at all the combinations, guys, how many are there? 1, 2, 3, 4, 5, 6. So there are total of 6 combinations, right? Very important. Order doesn't matter, right? So isn't it nothing but the same arrangement is there, and within that arrangement, you're removing the repetitions, correct? So when you say arrangement, you use permutation, right? So we can say NCR is nothing but NPR, the permutation. But in that repetitions, you're eliminating the repetitions. So divided by R factorial. You might be thinking, why divided by? Now, let me ask you a very simple question. What is repeated subtraction? Because when I say you keep on eliminating the repetitions, what is repeated subtraction? Division. That's why we divide by r factorial, because that is the repeated addition. Sorry, that's a repeated subtraction. You keep on doing repeated subtraction, that's nothing but division. So NCR is equal to NPR divided by r factorial. Or if you expand it, that is NCR becomes n factorial by n minus r factorial into r factorial. This is going to be the formula for NCR. Fair enough? So this is the theory behind NCR, or you can say combination. Now there are two important formulas, or most likely you can call them as theorems. Alright, so we need to prove those theorems. A very simple thing. Alright, let's do the two theorems. The first formula is NCR is equal to NC n minus R. So we need to prove it. It's a very simple theorem. So we'll expand and we'll do it. See, we know the formula for NCR, n factorial by n minus R factorial into R factorial, correct? So we'll start from the RHS, we'll come to LHS. The RHS part, that is NC n minus R, will expand using combinations. That is n factorial by n minus R factorial into n minus of n minus R factorial. Correct? Or n factorial by n minus R factorial into n minus n plus R factorial. N and n cancels. What do you get? You get n factorial by n minus R factorial into R factorial. This is the same as the LHS, isn't it? So what did we prove? Very simple proof. That is NCR is equal to NC n minus R. Now, to give you an understanding mathematically, or you can say theoretically, if n and r are very big numbers, we can use this particular formula. For example, if you have, say, 100C98, okay, you can't do 100 factorial by 100 minus 98 factorial. It's very big. Instead, do this 100C 100 minus 98, which is 100C2. This is very, very easy to do, isn't it? 100C2, which is nothing but 100 into 98 divided 99 divided by 2. Anyway, mathematical derivation is the math part, we'll do it later. Now it's only the expansion and trying to understand the formula. So 100C98 is the same as 100C2. Very, very simple. Correct? Now, second theorem. This theorem talks about another relation between the combinations. The theorem states that NCR plus NCR minus 1. This is n plus 1 CR. Okay, a little more complicated than the previous one, but very, very useful. Okay, extremely useful, especially in proving combinations and permutations part. Alright, so let's do the math. We'll start from the we'll start from the LHS, we'll come to the RHS. So in the LHS part, NCR, we all know what is NCR, which is n factorial by n minus R factorial into R factorial, right? Plus n factorial divided by R minus 1 factorial into n minus of R minus 1 factorial. Correct? Now what we can do, we can take common, right? So what you do, take n factorial by, so n factorial you can take common. First we'll do this, into 1 by n minus R factorial into R factorial plus 1 by R minus 1 factorial. So if you take this one, it's going to become n plus 1 minus R factorial. Correct? Okay. Next, what do we do? So, n factorial into, here we can write 1 by n minus r factorial into r, or let me write it in another way, this into r minus 1 factorial. Correct? R into r minus 1 factorial plus 1 by r minus 1 factorial to n plus 1 minus r factorial. Now we can take r minus 1 factorial as common, right? So you get n factorial by r minus 1 factorial 1 by n minus r factorial into r 1 by n plus 1 minus r factorial. Fair enough? This is what we have. But we have to further simplify this because we can't just keep it as it is. Okay? For that, what do we do is, we are going to take this and we are going to expand it. See, remember, what is factorial? You know that if you take 3 factorial, you know it's 3 into 2 into 1. That means you keep on reducing the value, right? So, n plus 1 minus r. So, let me do it here. N plus 1 minus r factorial. This is going to become n plus 1 minus r into n plus 1 minus r minus 1 factorial, correct? This and this cancels out. So what do you get? N minus r factorial or n plus 1 minus r into n minus r factorial, correct? So we'll write that here. Fair enough? N factorial divided by r minus 1 factorial into 1 by n minus r factorial into r plus 1 by n plus 1 minus r into n minus r factorial. Now we can take n minus r factorial common. We get n factorial divided by n minus r factorial into r minus 1 factorial into 1 by r 1 by n plus 1 minus r. Correct? Take LCM within the bracket. Forget about what is there outside the bracket. If you take LCM, n plus 1 minus r plus r divided by r into n plus 1 minus r. R and r cancels out. So what do we get? We get n plus 1 into n factorial, correct, divided by n plus 1 minus r into n minus r factorial, first part, into r into r minus 1 factorial. Isn't it? So what is this? N plus 1 into n factorial. This is going to become n plus 1 factorial divided by, what is this? We just split it, right? And we got back the same thing. That's going to be n plus 1 minus r factorial. And finally into r factorial. Correct? If you look at the combination formula, what we are going to get? This is nothing but n plus 1 CR. Right? So what did we prove? We just proved, so let me write it here itself. We just proved NCR plus NCR minus 1 is equal to n plus 1 CR. This is exactly what we were trying to prove. Fair enough? Now, I would recommend you guys to go through this derivation one more time so that you understand how do we go about it. Alright, so in the next video, we're going to solve few problems based on the concept, whatever we have learned.